Hi, my name is Megan Edwards of Focus Communications, and today we're getting the latest from GMG, which trades on the Canadian TSX Venture Exchange under the symbol GMG. Joining me once again is GMG's CEO and co-founder, Craig Nicol. Craig, we appreciate you coming on the show today. How are you doing?
Yeah, great, thanks. Great to be back on. Thanks, Megan.
So, Craig, for those new to the GMG story, could you please provide us a brief overview of the company and your energy savings and energy storage solutions?
Sure, not a problem. How about I go through some slides? Great. So GMG is now a 6-year-old Australian public company. As Megan said, we're listed on the Toronto Stock Exchange. Usual disclaimer for forward-looking statements for high-growth companies like ourselves. Very important to understand the early stage venture we are. We are a disruptive clean tech company that was formed to make graphene from natural gas, which enables a very high quality and low cost product, graphene, which we'll talk about shortly. That is tunable and is also very high quality, and that enables us to do a number of things with it, which we can go into. The proprietary process actually that we developed is held with a trade secret, and then the product patterns that we're looking to progress through that the graphene goes into also provides protection as well. We're targeting that graphene and the products we put that into energy savings and energy storage solutions. And most people love to hear about our amazing products, but most people want to hear about our graphene aluminium-ion battery, which we can talk about as well. So here's an overview of the company. We take natural gas straight from the grid or the street. We crack that through our proprietary process, turn that into graphene, and this byproduct is hydrogen. And then we put that into various different products, and then we actively sell or market or look to bring that into the market, these products, which are our thermal XR, our G lubricant, and our graphene aluminium-ion battery. The three markets that we're going into range about $150 billion worth of addressable market. The HVAC energy savings coatings is a product that we are targeting with the thermal XR. It's a market we're targeting with the thermal XR. And that's about energy efficiency and extension of life for the asset with reduction of corrosion with our coating. The automotive lubricant additives, or G lubricant, is a well-known market. It's been around for one of the longest markets that's been around for over 100 years. And that market we're well knowledgeable of with my background in Shell and the number of people in the company with backgrounds in Shell. And that is a less developed, but certainly it is. We've started to get commercial sales, and we're starting to see that come into the market. And its objective is to reduce the fuel that you use in your engine. And then the third and most interested party product that we get is around the graphene aluminium-ion battery, which is obviously a very large and very high growth market, which is mainly a lithium-ion battery, but this battery could even go into the lead-acid battery space as well. And we can go into that further, but that is the least developed product we have right now, and it's going to be more time to get to market to get there, but it is progressing well. The graphene aluminium-ion battery is a next generation battery, and it was developed by the University of Queensland, and we have an exclusive license for the use of that, which is a patent pending technology for battery cathodes, which is very exciting. Just that alone, it has the ability to have up to 70 times faster charging. It has also the life of 3 times or more of battery as well. So the number of charges it can take and discharges, it's significantly higher than what a lithium battery would normally see. It's also extremely green and safe with respect to its ability to have no fires, and from what we've seen, it's highly recyclable to a point where you can strip it apart and reuse the components at the end of its life. It has no lithium, no copper, no cobalt, manganese, or any rare earth materials. It's a very uncomplicated supply chain. It's just our natural gas with a byproduct of hydrogen, making graphene going into an aluminium battery. And we have ongoing intellectual property development with UQ and GMG.
Last time we had you on, we talked about the company acquiring the branding and manufacturing rights for Thermal XR, and more recently, over the past 3 months, you've had some updates from the battery division. Could you run us through some highlights from your battery performance press release?
Sure. So this is a chart of what we saw a year ago, which is a 3,000 cycle test where it continued to work at very high C rates, very high charging rates, and that's a very good energy density over 3,000 cycles, which you really couldn't do with a lithium battery as it stands now. But then what we announced in this October was almost a doubling of our energy density. So you can see there it went from about 150 calculated energy density to around 300 watt hours per kilogram energy density. And what we've also seen is an increase in our ability to charge and discharge. That rate, that power density has also gone up as well. So both rates are now fairly squarely in leading positions in and around the world kind of space around batteries for energy density, and definitely for a power density of such fast charging opportunity there. So that's the main thing we updated off in October. Now here's a visual representation of that, showing you where our calculated energy density of around 290 is around compared to the two grey bars, which is where a lithium ion battery currently sits, although there are other batteries out there. But those are the two that might be higher than that or are higher than that. But those are the two bulk batteries that are probably the largest batteries sold in the world, the two lithium batteries there in grey. So how did we get this increase in energy density? Well, it came through two different variances. One was an increase in the nominal voltage from 1.7 volts to 2 volts. And then the other one was an increase in the specific capacity, which is really quite exciting. And that means that those two will also carry through to their performance characteristics. And it's something that we feel quite happy about to get to this next level only after a year. I guess the important point is that there's a lot left in this battery. There is an opportunity to increase the volts even higher, and there is an opportunity to increase the specific capacity. But what we're working on now is making sure that we can get a dependable, successful pass rate for these coin cells and optimize it going forward for new battery engineering, which we can go through shortly.
And I know the ongoing work on development within the battery division. Is there anything in particular that the team is currently focused on as you can continue to progress towards commercialization?
Yeah, so there's a number of things we're working on there, and it's a very complex piece of optimization and progress and development around the battery. There are a number of different parts to the battery that we're working, optimizing and progressing. We have the substrate, which is where the cathode comes onto. We have the separator, and we have the anode, which is aluminium foil, and then we have the electrolyte, which is the liquid that goes in between the aluminium salts. And we are trying to optimize every one of those to progress to a readily definable, scalable outcome that produces a good quality battery that people will buy every time we produce. So that's the space we're in now, which is really exciting because that means we've progressed into this next space of optimizing into an engineering outcome. We've kind of broken the back of the science, which is really good. Now we need to optimize the engineering of the materials to get to a place where we can grow the actual applications for this battery and start to look about at which ones we could produce in time. The other space we've done is we've optimized our graphene around the battery, and we've been able to see that we could make a a scalable graphene plant for the battery in a repeatable manner, which is really quite exciting. That's the one thing that I think, as a graphene producer, you want to be able to make graphene pretty much every time to be able to make a good battery. And we've seen enough data now to actually say that we think we've got repeatable battery-grade graphene coming for our battery. But we obviously continue to do more work there, and we'll continue to optimize our graphene to make the battery better, because it is, in the end, all in the graphene.
And the company is well-funded going into next year, and most recently has announced an additional investment into the Battery Development Center. Can you discuss some of the use of funds from this announcement?
Yeah, this is the next step for us, and it's a big deal for our company. We've only a year and a half ago, we said we wanted to be a battery company, and here we are now developing into the next stage of our battery progress. This capital announcement is the next stage of producing the pouch cells. So we're producing pouch cells manually right now, which is a good way to test how they work and how you can get a pouch cell to operate. Now we need to be getting to that next stage of semi-automation, because pouch cells is a number of windings or stackings that mean you end up having a lot of manual issues if you have to do lots of stackings just for one pouch cell every day. So automation really starts to help the consistency of the battery, which is very important to, as a battery producer. The consistency is, in the end, what people will buy. And so first of all, there's a stacking, if you will, like a robot that enables some semi-automatic pouch cell manufacturing, but it's only of one stage of the 8 stages of making a battery. Then also we've got other testing equipment to be able to really understand our batteries. One's called a potentiometer, which understands how the electrolyte and the various different types of parts of the cell operate. And that'll also further testing equipment and upgrading of our testing room. So that there's a good, I think, progress outcome from this is that we'll start to really understand the pouch cell a whole lot more, and with many more pouch cells being made per week than manual, we'll have more examples of how good our production rate is and our repeatability. The other thing that probably is not clear on this slide is we've started to engage a number of potential battery customers. And that's really exciting. So we'll start to, and we've already got one signed, and we'll progress through a number of non-binding term sheets, which will enable us to develop a battery for that customer, obviously with the mind of hopefully, if it does work, to potentially produce it for them. So we're starting to go into those what I would call discussions around those framing development agreements. And we will likely have, most of those signed by early next year. They're all confidential, and I don't think we will actually be announcing any of the names for some time. But we've had a number of companies who've asked us over years to talk to us about our battery and wanting to work with us. And so we've had that, I think, over 500 companies or so globally request for working with our company. And we've had a good range of companies to pick from, and we've gone through all the various different applications and countries, and we've sought to optimize around a product that we could potentially try to commercialize as fast as possible, but also ones that will be really long development, but huge opportunity, huge market, huge players. So good mix of potential battery customers, and they're in everything from personal electronics through to the full range of mining or high power density, electric aviation. We should see some electric vehicle developments, and then a number of other type of applications that including e-mobility. So there's a range of applications, and we'll we'll look to finalize those, and we'll then be able to make these batteries, share them with potential customers, and start to target next year where is the best space for our pouch cell to work in, because you can't do this one-handed. You need two hands, but you can't have too many customers in the loop. Otherwise, we won't be able to focus. So it is important process to get to this, to then go into this space of integration with customer demand and use specifications per application. And I'm really proud of our company to get here, and I'm very, very excited about doing this next year. So the next area is I guess what are we looking for next year? We're still working through our coin cell development, and we've already got a $1.5 million graphene production center, and for the graphene expansion, and that's also being located next to our battery development center. So that project's already been kicked off, and we're looking at seeing how we could do an investment in a coin cell factory next year, and then hopefully looking at a production of that factory in 2024. The coin cells are much easier to be able to produce genuinely, although we're still working through the engineering of how all that will come together. And then the market is a known market, and you've got a definable product, and hence that's one of the few spaces where you can go in a battery without having too many concerns. Is it going to meet customer requirements? But also at the same time, we're working through our pouch cell opportunities, and as I said, we'll have a really good review of what type of applications our batteries, our pouch cells such as these, would be able to work with. And we're continuing to work and grow that over time in terms of who we'll be working with, and then we'll look to have a review of that with respect to our technology and our market development, and so that we can then be able to know which type of integrated gas to graphene and automated pouch cell manufacturing sites we could look to bring for what applications in which countries. The battery has definitely progressed somewhat since we first made the decision in 2021, and we really are now launching into the next stage of our development phase, which is really something. As we said, it is progressing quite fast, I'd suggest, and we've got to keep the momentum up. But we're now going into a pretty intense customer application and work with them and understanding that, and that's what we hope to do next year. And that probably concludes the slides, but any further questions?
Yes, I was going to say, we really appreciate you coming on this show with us today, Craig. Before we let you go, what are the catalysts in 2023 that our investors can look forward to from GMG?
Yeah, so we're really pushing hard on the Thermal XR sales and a distributor network around that. That's really exciting. And we really hope to come to market with something on that, but until it's done, it's not done. Then we really hope to kind of further release on our product roadmap or / market map for our batteries. That's also really exciting, and I think there's a huge opportunity to progress that next year, as we've discussed. The graphene lubricant space is going to get more exciting next year as well, as we progress to some larger customer trials. We've already got customer orders in from Asia, and we'll continue to grow that, I believe, next year. It's a sleeping dark horse in our product portfolio. We don't get to talk about it much, but it is really another amazing product. Thermal XR will continue to show how we can move heat with that product and over different materials and different temperature ranges. And we should be able to come out shortly and say we've switched on our new coating development and production lab, which is kind of under construction right now, after purchasing the IP and the rights to that product earlier this year. So lots of progress We should also by mid-year have, we expect to switch on our new graphene plant, which is, for all intents and purposes, fully automated apart from the packaging side. And that will be the next generation of our graphene production technology coming to fruition. So lots of things that I can't say exactly which one will come first, because it is a very exciting space right now, and lots of things I think that will probably come in on top of that as well, which is very exciting.
And Craig, we want to thank you once again for your time today and for giving us the latest from GMG. We look forward to having you back on again very soon to discuss more updates from the company.
Thank you, Megan.